going to zero the scale. See, it is now 0, so we can now measure the beaker. Placing the beaker inside. There's the mass of the beaker, 29.543 grams. Now I'm removing the beaker from the machine.
You don't have to zero it up.
And I'm going to pour the water from the beaker, which is 10 milliliters of water from the graduated solar into the beaker.
So I found the density in here.
Now I'm going to zero the scale again.
No, don't zero it. Just put it in here.
I'm going to zero.
Where's the sugar? That's not our. This is ours.
Placing the beaker on the scale with the water. There's the math. There's the math with the water. 38.353 grams. Then find the mass of just the water. The mass of the beaker in the water with the mass of the beaker. Find the mass of the water. Please calculate density. We'll use volume and mass.
Hi, my name is Keaira. Today we're going to balance the mass of water. So first we're going to zero out the balance. Then we're going to place the beaker in the balance. Okay, the mass of the beaker is 29.655, and the uncertainty we saw in the video as we're going through it is because of slight movements towards the balance and other things like shifts on the tabletops. So now we're going to take it out, and we're going to put 15 mils of water. Then we're going to put it back in the balance. Close it. And the mass of the beaker and the water is 42.500 grams. As we see on the graph on the balance, it's actually doing the uncertain shift as well again. Because as I said, we're doing slight movements by the balance. And when we subtract the mass of the beaker of the water and the mass of the beaker, we're going to get the mass of the water, which we will and then get the density of water.
My name is Susan, and I'll be doing the same thing. Start the new beaker. Place the beaker in. The initial mash is 29.99. 36.283.
These are sharks.
And then subtract these to get the mass, and then that gives you the density.
As you notice, we use the same scale. All our measurements. It's important that you use the same scale. It can lead to possible error in our experiment if you don't, because each scale weighs slightly different. Hello, my name is Nikki Vallor, and we are going to be getting the mass of water, but we are going to be using a pipette this time. So let's begin. I'm going to zero the scale. Now I'll be placing the beaker in the scale to get the mass of the beaker. The mass of the beaker is 27.558 grams. Now I will remove the beaker from the scale. Now I'm going to get water using the pipette. I am doing 2 milliliters of water using the pipette. Now I'm placing this in the beaker. I will now get the mass of the beaker with the water. And the mass is 30.865 grams. And once again, we will be calculating the mass of the water by subtracting the mass of the beakers. We will calculate the density using the volume that we just measured and the mass. And once again, we are making sure to use the same scale as to not present any error in our experiment. And also there is uncertainty again with the numbers on the scale, just because of movements of things moving in and just uncertainty in general with weighing on a scale with this uncertain digits.
My name is Susan, and we are measuring the balance using a pipette this time. First, I'm going to set the machine. Place the empty beaker. 27.688. Yeah, I can measure. Five milliliters. Place it in. Mass is 32.902.
So 17 milliliters of this.
And then we do the same thing. We subtract the mass of the beaker and the mass of the beaker in the water and the mass of the beaker to get the mass. And then we do the same thing again.
there are